Okay, I want to spend a little bit of time here talking about getting the remainder of a division, and the reason we want to look into that is because there's this very nice, cool tool that we can use in Python and in any programming language, or the majority of them, that gives us the remainder of a division. And now you might not think it's a big deal, but it actually helps with a lot of programming applications. So what I want to spend time here is describing basically this what we call the modulus operator. Modulus. And the way we denote the modulus operator when we're programming is by using a percent symbol like that. Now, what you get when you use the modulus operator is you get the remainder of a division. Now, we're not used to working with remainders when we divide, but we've seen them. And so let's suppose that we have a number that we're dividing by another number. In this case, let's say that we're going to divide, and this is just an example. Actually, let me use a different color here. Let's say that we're going to divide excuse me there we go. We're going to divide the number 10 by 4. And so if I divide 10 by 4, and if we just do it the old school way, so without a calculator, we just take 10 and we put it inside this little division house. I don't know how you learned or how you learned it, but we put the 4 outside and we say, how many times does 4 fit in 10? And then the answer to that is 2. And then we proceed to multiply 2 times 4 to get 8. And then we subtract 10 minus 8 and we get 2. And then we can say, we ask ourselves again, if there was another number, another digit here after the 10, there isn't. We'd bring that digit down like that, but that's a different problem, so we don't. Now we ask ourselves, how many times does 4 fit into 2? And the answer is 0. 4 does not fit into 2. And at this point, we stop. Now, we would, if we wanted to divide the usual way, we would put a point here and add a 0 and bring that 0 down and then divide, and we place the point, and 4 goes into 25 times, right? 2.5. Final answer would be 2.5. However, the difference right here when we're trying to get the remainder is that we don't follow that step. Instead, we say that this 2 is the remainder of the division. And that's it. And so using this modulus operator, which is a percent symbol, we can take 10, and instead of dividing it by 4, we can say 10 mod 4. Again, I'll write this out, 10 mod, short for modulus, 4, equals 2, where the 2 is the remainder that's coming from there. And so we can do this operation with other examples. And we can say, for example, and I'm making these numbers up, okay? 17, for example, modulus 7. And you can carry out the process, so we can take, okay, we're going to divide 17 divided by 7. And 7 goes into 17 twice. And 7 times 2 is 14. And we subtract, and we get 3. And in this case, 7 cannot fit into 3, and so we call the 3 the remainder. And so the answer would be 3. And again, we can continue. And I'm just trying to give you as many examples, if anything, just to make sure that we feel more and more comfortable getting the modulus or the remainder when we perform a division of two numbers. So let's do one more example here, at least, maybe a couple more. Again, I'm just thinking of numbers off the top of my head. 56 modulus 5. And I think you can once again do the operation, but I want to give you another perspective here, which is think of the biggest multiple of 5. So biggest multiple of 5 that is less than 56. And so, meaning by multiple, I mean the table, the times tables of the fifth row. And so let me write the multiples of 5. 5, 10, 15, 20, and then you keep going. And the biggest multiple of 5 that is less than 56 is 50. Actually, 55, right? And I'm going to take that biggest multiple, and I'm going to simply subtract 56 minus the biggest multiple, 55, and that gives me the remainder, so 1. And again, just a couple more examples here. I'm not going to drag on too long, but the objective is for you to feel comfortable with the modulus. And so we take, 37 modulus 10. And you ask yourself, what's the biggest multiple of 10 that is less than 37? And I write the multiples of 10. 10, 20, 30, 40. And obviously 30 is the biggest multiple that is less than 37. And so I simply subtract 37 minus 30, and that would be 7, which means that the remainder when I divided 37 by 10 is 7. Now I'll stop here because now we actually want to implement this in Python, and I want to show you how this works. And so I'm going to take this attach my computer here. So in Python, I'm going to create this new file called modulus. So by all means, go ahead and follow along, and I'm going to define the main function. And I know that after I define the main function, I'm going to execute the main function. So we should always start our Python files like this. Notice that after I press enter here at the end of the definition of the main function, it automatically indents for me. And that's important because if it doesn't, you have issues with your code. So I'll make two variables here, num1 equals, and I'll make it up, 8, and num2 equals 3. And I'm just going to print num1 modulus, which we use that percent symbol, num2. And before you run this, I want you to think, okay, when I divide 8 by 3, what is my remainder? Or 3, what's the biggest multiple of 3 that fits into 8? That would be 6, and 8 minus 6 is 2. So I'll test it. I get 2, great. And now I can play around with these numbers a little more. So maybe we can put here 70 and 9. And again, 70 divided by 9, the biggest multiple of 9 that goes into 70 is 63, right? 63, and 70 minus 63 is 7. Great, so hopefully we're starting to get a handle here on the modulus. And recall, I want to show you one more thing here and this is for the homework assignment. I'm trying to make this video geared at the homework assignment. So let's say that we divide num1 by num2 here. Print num1 divided by num2. And if I run this, I get 7.77, right? It includes the decimal here. Now, in the homework, you're going to be asked to do something that requires you to write the division of 70 divided by 9, its answer as 7 with the remainder of 7. So what I would want you to do here is when you divide 70 by 9, your answer is 7 with the remainder of 7. That's what I want you to print. And I'm going to try to share here some of the stuff you'll need for that. When we want to divide two integers, because num1 and num2 are integers, they're whole numbers right there. How would I make them so that they're not integers? I would put a 0.0. Now those are not integers. They're not whole numbers. Java thinks of them a little differently. It thinks of them as what we call doubles or floats, floating point numbers, more accurately, floating point number. In a floating point number, you can store decimal values. And that has a lot to do with the accuracy of the floating point number and the bits that you're storing here. But when you don't have the 0.0 here, we call this an integer. And usually we call it int, short. And an integer is just a whole number. And we don't have to deal with data types explicitly in Python like we do in Java, but the data types are still there. And what we can do though is, so we have an integer 70 and then another integer 9, and we start getting comfortable with the word integer and with the word floating point number. And when I divide num1, which is an integer, by num2, which is another integer, what if I want to keep an integer as my answer? So not as 7.77, but instead just 7. Well, I can use the int function from the previous video, put it in front right here, int, and then put the set of parentheses and make sure you're balanced, because when you're not balanced, notice how the red line shows up. This red line shows up because I have an open parentheses here. I have another open parentheses, but I only have one closing parentheses, so I need an extra one. Notice how it turns green. Those two match with each other, and if you put the cursor here, those two match with each other, and then these two match with each other. And you always need to be balanced. You always need an even number of parentheses in your code. Now let me explain what happened here. When I take num1 and divide that by num2, I get 7.7777 repeating. But putting it inside of the int function, like I'm doing here, this is the int function, and I'm putting it inside of the parentheses, so that means I'm putting it inside, will make my answer an integer, which means it will make it a whole number. But it's not going to round up to 8. It's just going to forget about anything after the decimal. So we call that truncating. So the int function, let me put this in a comment. Suppose that I sent the number 8.5 to my int function, which means I'm making 8.5 an integer. The int function returns 8. Not 9, 8. And I'll make it a little more here, 8.8 for example. If I send 8.8 to the integer function, it's going to return 8 and not 9. It's not rounding. What it does, it returns 8 because everything after the decimal is truncated. That means it's chopped off. We just get rid of anything after the decimal. So now if I run this, I'm taking 70, dividing it by 9, and I get 7, and I'm getting the remainder afterwards. Now we're getting 2 7s, so that may be a little misleading. Let's change the numbers here a little bit. Let's instead do something like 75. Divide that by 9. Well, that would be 8, because 9 times 8 is 72. So 8, and then when I subtract 75 minus 72, I get 3. So it would be 8 with a remainder of 3. And so I run this, and I get 8 and 3. And so that's what you're going to be doing in this homework assignment. Again, For this specific example, I'm okay with making it a little more geared towards the homework assignment, and hope this helps.